click this, you can see a summary of the things that we have set yesterday. So the base calling model is 5 fast base calling, and then the Q score is 8. So altogether the number of bases is 1.22 and the base call reads is 1.18. So this is the summary of everything. Yeah, then this is the PAW activity. You can see that it's quite good. So how we see the PAW occupancy, you can just untick all this. Then you can see the PAW occupancy. So light green is the one that is sequencing. So you can tap your finger on it. Then you can see that the sequencing is 90.2%. So the PAW occupancy of, I think, above 80% is considered relatively good. So this is a very good PAW occupancy. Yeah. There's this blue color part, inactive, right? It comes inherent in this flow cell. Because remember when we tested this flow cell, it was only 800 plus. So it could be all these inactive pause really. Yeah. Then yeah, this is the pause scan. So pause scan is also called mark scan. So it occurs every 1.5 hours. So it will just purge out whatever that is sequencing and then to test which is the best.
They automatically scan the pause.
Yes. So by default it's 1.5 hours, but the customer can make changes. Like maybe they don't think they need so many pause scan, then it's like 3 hours. But we usually recommend to leave it as default, 1.5 hours. Because sometimes when the contaminants get blocked, right, you want it to purge out and then to see whether the pause can still be used. So if you don't do a mark scan, then it will get blocked very rapidly. Then you can't really sequence much. Okay. This one is
So now the for remaining is around 500.
Yeah, around 500. Then this one is the cumulative output. So this is the red one is those that failed the reads, which is failed the Q score of 8. Then the green one is those that have passed, and blue is the total read. So it's like pass and fail read combined together, you get the blue one. Then this is the read length histogram. We can see that the estimated N50 is 6.83. So yesterday when we were checking, right, it's 3 KB when we started sequencing. Yeah, so it slowly increased. Yeah, this one you can actually,
Because the shorter fragment will read.
yeah, move, will be sequenced faster. Oh, I don't know why this one cannot. But if you use like remote access to the computer, right, you can actually minimize so that you can see this. Yeah, then this is the translocation speed. So we want to see whether the reads has been translocated through the pause at a constant speed of around 400. So this is acceptable because it's within the green color region.
Oh, so if outside the green color,
Then there could be some problem with the sequencing run. So for Mark 1B, right, because it doesn't really have a temperature control compared to Mark 1C. So if you put it near a computer, you know the vent, there's a heat vent, then this translocation speed may increase because it's too hot. Or if the lab is too hot, then it may also increase. So for Mark 1C, it should usually be quite constant. So if your translocation speed like is affected, right, your Q score will also be affected. But for ours, it's relatively constant, so it's fine.
above 8, right?
Yeah, then this is the barcode hit. So we have 4 barcodes. So you see there's like some at barcode 10, like pass read 3. So this I think usually they are all failed reads, but they are here. So sometimes there's some error in reading the reads with the barcodes. So you can see the majority
The
are
majority is 1, 2, 3, 4.
Yeah. Then this is the temperature. So the temperature should be around 36 degrees. So okay, it's quite constant. Yeah, so this is the bias voltage history. So this is also quite constant. So if you see this voltage is drifting upwards or downwards, then it could be some issue with the run also. So this one is okay also. Yeah, so this one is the disk write performance. So how much data has been written into the disk of this. So this one.
On this device.
On this device. So you can see it's around 16 GB. Yeah, so that's all.
Not for our running yesterday, right?
Yeah, this is for your running yesterday.
Oh,
So
the total is 16 GB.
because you only ran for 5 hours. Yeah, so we will auto generate a run report for each run. You will usually, and when you end, right, it will auto generate unless the run is like crash, then it will not generate, but usually it will generate. So when we transfer this data over, I think today or tomorrow, when on Thursday or Friday, we will show you the run report of your runs, and you all can try to analyze this. Have you all tried using Epi2Me before? Epi2Me Asian, Epi2Me dummy data. Okay, so you can try using this lambda data and then do an alignment to see whether it's to the reference lambda. So you can do it on Thursday. Yeah, on Thursday.